Hi, today I want to walk you through an AI-powered microservice that I built for an healthcare app. The problem is that critical patient messages often get buried under hundreds of just routine questions about clinic hours or basic supplement updates. I built this project exactly to solve that. It intercepts unstructured patient messages, uses an LLM to classify the intent, urgency, and so on, and then it instantly routes it to the correct team. Now, here is the architecture. A patient message comes in via webhook, hits my Python server, and comes back as structured data. Then this router splits it into three paths: emergency, standard plan change, and just a fallback for general questions. But my main idea was that relying on AI for medical routing is kind of risky due to possible AI hallucinations. So the actual heavy lifting happens inside the custom backend microservice that I built using Python and FastAPI. Here it is. I deliberately decoupled the AI logic from the routing platform so that I have complete control over the OpenAI integration. Obviously, the API key never touches the front end. It lives in .env file and is loaded securely at runtime. Also, I added rate limiting against accidental loops, which could cause massive bills. So instead of relying on free-form text, I implemented OpenAI Responses API with a strict Pydantic schema acting as a bound. Using Python literal constraint, it's simply impossible for the AI to return bad data. I forced the model to return exactly one of three strings: plan change, emergency, or general question. This guarantees that make.com router always receives clean and predictable JSON. Now, this single call sends the message, enforces the schema, and hands back a fully typed Python object. The model returns four structured fields: the intent, the possible urges, uh, the supplement suggestions, and also critical. It assigns an urgency score from 1 to 10. The Pydantic schema enforces every single field, and then the make.com router then uses that exact urgency score uh, as the trigger condition. If OpenAI also fails or returns anything unexpected, this error handling catches it and returns a clean response like this instead of just crashing. So the emergency route fires when urgency score is greater than 8. It's a hard numeric threshold, not a text match. That's exactly why decoupling the AI from the router matters, in my opinion. Make.com doesn't need to interpret the language. It just checks a number. This way there's just no room for error. Now let's run a live test. Here I prepared a command with a message: I just took the new supplement and my throat is filling up, I can't breathe. Now we run it. We see that urgency score assigned is 10. Seek immediate medical attention, supplement recommendation, allergy warnings, no intent, emergency. And here's what we get. We get the email, not we, just The on-call nurse receives the exact message. So here, warning, patient intent is emergency and identified allergies, throat swelling, and difficulty breathing. So it's everything they need to call their patient immediately. Now, I also run some tests uh, with the standard plan change option. The question was that client was taking magnesium and vitamin D, and he wants to change some supplements for his energy levels. Here is what the department gets. Good day, we're processing requests. Suggested supplements for now, blah, blah, blah. So this message, the correct department can just copy paste and send to the client. And general support, here it is. A patient has submitted general query that requires a human response. Here is the original question. What are the benefits of taking omega-3 supplements? So here, yeah, it requires a human response. So the goal of this project wasn't to replace humans. It was to use AI to read inbound data, structure it, and get it to the right person or department instantly.